Alright, so in this problem, I have 5 to the power of x plus 5 to the power of x plus 5 to the power of x plus 5 to the power of x is equal to 1,000. So I'm going to first start by factoring out 5 to the power of x. So now I have 5 to the power of x times 1 plus 1 plus 1 plus 1 is equal to 1,000. Now, if I simplify what's in the parentheses, 1 plus 1 plus 1 plus 1, that's 4. So I have 5 to the power of x times 4 is equal to 1,000. Now I can divide both sides by 4. So then these two cancel out, and now I get 5 to the power of x is equal to 1,000 divided by 4, which is 250. Now, 250, I can rewrite this as 25 times 10. So I have 5 to the power of x is equal to 25 times 10. And 25, that's the same thing as 5 squared. So now I have 5 to the power of x is equal to 5 squared times 10. Now what I'm going to do is I'm going to take the log on both sides. So now I have log of 5 to the power of x is equal to log 5 squared times 10. And now an important rule to note down is that if I have something in the form log a to the power of b, I can actually move this exponent b to the front. So this is going to equal b times log a. So in this case, I have log 5 to the power of x, and we can think of x as b in this case. So I can simply move x to the front. So now I'm going to have x times log 5 is equal to log of 5 squared times 10. Now, we obviously want to find the value of x, so to do that, we're going to have to isolate it. And to isolate x, we're going to have to get rid of this log 5 by dividing both sides by log 5. So then these two log 5s cancel out, and then I get x is equal to log 5 squared times 10 over log 5. Now if I have something in the form log a times b, this is equal to log a plus log b. So log 5 squared times 10, that's going to equal log 5 squared plus log 10. Now I have this over log 5. Now remember how if I have something in the form log AB, I can move this to the front. So now I have x is equal to 2 log 5 plus log 10 over log 5. And log 10 is equal to 1. So I have x is equal to 2 log 5 over log 5 plus 1 over log 5. These two cancel out, so I get x is equal to 2 plus 1 over log 5. Alright, so in this problem, I have 4 to the power of x is equal to 40. So to solve this, I'm going to start by taking the log on both sides. So now I have log of 4 to the power of x is equal to log of 40. Now, if I have something in the form log of a to the power of b, I can move this exponent b to the front. So this is going to equal b times log a. So in this case, I have log 4 to the power of x, and I can move x to the front. So now I'm going to have x times log 4 is equal to log 40. Now I'm going to go ahead and divide both sides by log 4 so we can isolate x. So then these two log 4s cancel out, and I'm going to be left with x is equal to log 40 over log 4. Now we can rewrite log 40 as log of 4 times 10. And if I have something in the form log of a times b, this is equal to log a plus log of b. So log 4 times 10, that's going to equal log of 4 plus log of 10 over log 4. And if you guys already know, log 10, that's actually equal to 1. So I have x is equal to log 4 plus 1 over log 4. Now, I can rewrite this as log 4 over log 4 plus 1 over log 4. Now log 4 and log 4, these two cancel out. So I have x is equal to 1 plus 1 over log 4. Now log 4, this is equal to 0.602. So I get x is equal to 1 plus 1 over 0.602. And 1 divided by 0.602 is 1.66. So 1 plus 1.66 is 2.66. Alright, so in this problem, I have x to the power of 2 minus x to the power of 3 is equal to 12. So I'm going to first start by rewriting this as negative x to the power of 3 plus x to the power of 2 is equal to 12. And from here, I'm going to multiply both sides by negative 1. So now I get x to the power of 3 minus x to the power of 2 is equal to negative 12. And now, finally, I can add 12 on both sides. So now I get x to the power of 3 minus x to the power of 2 plus 12 is equal to 0. Now I'm going to rewrite 12 as 8 plus 4. And I'm going to actually move some terms around. I'm going to move 8 next to 8 to the power of 3. So if x to the power of 3 plus 8 minus x squared plus 4 is equal to 0. And 8 is the same thing as 2 to the power of 3. 4 is the same thing as 2 squared. If I have something in the form a to the power of 3 plus b to the power of 3, this is equal to a plus b times a squared minus ab plus b squared. And a squared plus b squared is equal to, a squared minus b squared is equal to a plus b times a minus b. So in this case, I get x plus 2 times x squared minus 2x plus 4 minus x plus 2 times x minus 2 is equal to 0. From here, I can factor out x plus 2. So I get x plus 2 times x squared minus 2x plus 4 minus x plus 2 is equal to 0. And if I simplify this, I get x plus 2 times x squared minus 3x plus 2 is equal to 0. Sorry, minus 3x plus 6 is equal to 0. Now, I get two equations from this. I get x plus 2 is equal to 0, and I get x squared minus 3x plus 6 is equal to 0. So for x plus 2 equals 0, x is obviously equal to negative 2. And for x squared minus 3x plus 6 equals 0, we have to use the quadratic formula. And I'm not going to waste your guys' time by actually plugging these into the quadratic formula, but the final answer is that it's actually going to be rejected because the square root is going to be negative, and you can't take the negative of square root. So my only answer is x equals negative 2. Alright, so in this video, I'm going to solve the problem 32 to the power of 200 minus 2 to the power of 999. So to solve this, I'm going to first rewrite 32 as 2 to the power of 5. So I get 2 to the power of 5 to the power of 200 minus 2 to the power of 999. And this turns into 2 to the power of 1000 minus 2 to the power of 999 because the 5 and 200 multiply. Now to solve this, I'm going to rewrite 2 to the power of 1000 as 2 to the power of 99 plus 1. So I get 2 to the power of 999 times 2 to the power of 1 minus 2 to the power of 999, which is equal to 2 to the power of 999 times 2 minus 1, which is equal to 2 to the power of 999. Alright, so in this video, I'm going to solve the equation 1 to the power of x plus 10 to the power of x is equal to 100 to the power of x. So, to solve this, I'm going to first start by rewriting this as 1 to the power of x plus 10 to the power of x is equal to 10 squared to the power of x. Now from here, I'm going to look at the term 1 to the power of x. Well, let's say we have 1 to the power of any number, like 1000. This is still equal to 1. And even if we have 1 to the power of infinity, this is still equal to 1. So no matter what value x could be, it's still going to be 1 to the power of x will still be equal to 1, meaning we can just ignore the x and just say this is 1 plus 10 to the power of x is equal to 10 squared to the power of x. Now from here, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. And a to the power of m times n is the same thing as a to the power of n times m. Well, if these two are the same, and a to the power of m times n is equal to a to the power of m to the power of n, this should mean that a to the power of n times m is equal to a to the power of n to the power of m. So in simpler terms, a to the power of m to the power of n is equal to a to the power of n to the power of m. So, for 10 to the power of 2 to the power of x, I can switch the values of 2 and x. So now I get 1 plus 10 to the power of x is equal to 10 to the power of x to the power of 2. Now from here, I'm going to let 10 to the power of x equal to the variable y. So if I substitute in y for 10 to the power of x, I get 1 plus y is equal to y squared. Now I'm going to subtract y and 1 on both sides. So I get y squared minus y minus 1 is equal to 0. Now, what we have here is a quadratic equation. And to solve this, I'm going to be using the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, I'm going to look at the coefficients. A is 1, b is negative 1, and c is negative 1. So I get y equals negative of negative 1 plus or minus the square root of negative 1 squared minus 4 times 1 times negative 1 all over 2 times 1. And now this is equal to 1 plus or minus the square root of 1 plus 4 over 2, which is equal to 1 plus or minus the square root of 5 over 2. So I get that the value of y is equal to 1 plus or minus the square root of 5 over 2. However, we aren't done yet, because remember, we're solving for the value of x and not y. And we let 10 to the power of x equal to y. So I get 10 to the power of x equals 1 plus or minus the square root of 5 over 2. Now, this gives me two equations. I get 10 to the power of x is equal to 1 plus the square root of 5 over 2. And I get 10 to the power of x is equal to 1 minus the square root of 5 over 2. So I'm going to first start with 10 to the power of x is equal to 1 plus the square root of 5 over 2. Well, to solve this, we want the x over here, which is an exponent, to turn into an actual term. And to do that, we're going to use logarithms. So I get log 10 to the power of x is equal to log of 1 plus the square root of 5 over 2 when I take the log on both sides. And now, if I have something in the form log a to the power of b, I can move this exponent b to the front, so this turns into b times log a. So I can move x here to the front, and I get x times log 10 is equal to log of 1 plus the square root of 5 over 2. Now, I'm going to divide both sides by log 10 because x, we want to isolate x. So these two cancel out, and I get x is equal to log of 1 plus the square root of 5 over 2 over log 10. Now, if you already didn't know, log 10 is equal to 1. So x is simply equal to log of 1 plus the square root of 5 over 2. And now the exact value of this is 0.209. So this is one solution of x. However, don't forget that we have the equation 10 to the power of x is equal to 1 minus the square root of 5 over 2. So to solve this, we're doing the same thing. We're going to be using logarithms. So I get log 10 to the power of x is equal to log of, this time 1 minus the square root of 5 over 2. Now I can move x down, so I get x times log 10 is equal to log of 1 minus the square root of 5 over 2. And we don't even have to divide both sides by log 10 because we already know log 10 is equal to 1. So we can just get rid of it, and I get x is equal to log of 1 minus the square root of 5 over 2. Now, the log of 1 minus the square root of 5 over 2, the exact value of this is actually going to be negative 0.209 plus 1.364i. So there is an imaginary number in this. So this is my second solution to this equation. Now, if you haven't already, please make sure to subscribe, leave a like, and share this to any of your friends or family. Thank you.